Can you guys hear me? Cool. I can start now. All right, so we're going to talk about Allora. It's a project we've been working on for a while, and instead of talking about capital fragmentation, a lot of what we're going to be talking about with Allora is more around AI fragmentation and how we kind of are able to build AI, leveraging the power of kind of decentralized coordination networks and markets. So just as kind of a level set, we're going to start by kind of like aligning on what we see as kind of the AI stack and how these different pieces fit together. I think when a lot of people talk about decentralized AI, they talk about it as this kind of single amalgamous like stack of technologies. It is all kind of bucketed together, but in reality, we see the stack kind of consisting of kind of four distinct or primary modular layers that are kind of stitched together in that modular fashion. And those layers are data, compute, execution, and this kind of intelligence layer or model layer of the stack. And we think it's ultimately going to be sort of realized in this modular form factor because this is more or less the more optimal way to build decentralized networks. When you're building a decentralized network, you're already trying to build rule sets, build mechanisms to coordinate disparate actors to kind of do certain tasks. And when you introduce heterogeneity into that, when you're trying to build monolithically and support many distinct actor types across many distinct task types, your complexity compounds quite quickly, and therefore the sort of soundness of network or mechanism design degrades quite quickly. And so we think this kind of modular AI stack with each layer focused on a kind of core problem set within the broader AI problem in its decentralization is the more optimal way to go about approaching this. And today we're going to be talking about this kind of intelligence layer of the stack, this model layer of the decentralized AI stack. And the core problem here that is kind of plaguing AI generally, not just in its decentralized form, is this problem of siloed machine intelligence. We have lots of models that exist, but they exist in these kind of isolated silos. We can't easily take n models, merge them together, and produce a new form of intelligence or a new model that represents the sum of intelligence of those underlying models. And what this results in is one, like a meaningfully a diminished curve of progression or rate of progression for AI. Obviously, we can't enable like the full breadth of powers that markets and sort of decentralized networks of actors can enable when each model is sort of locked in its own silo. And we also end in this kind of composition of the AI market that we're increasingly getting into today, where there's a few monoliths with access to the most raw resources that contribute to producing useful AI, like data and compute, creating increasingly better models, expanding their lead from the rest of the pack, and sort of introducing this kind of inherently suboptimal market structure in AI as it exists today. So this is the core problem that I think decentralized networks tackling this intelligence or this model problem are targeting, is solving this problem of how do we create networks where many different AIs, many different models can coordinate together to create increasingly better intelligence or machine intelligence. And so that's what we're trying to build with Allora. Allora is a model coordination network that basically aims to enable many different models, many heterogeneous sources of machine intelligence to collectively optimize different ML objectives, solve ML problems together, learn off of one another, and creating this kind of aggregation layer for AI. And this kind of tackles this core problem of AI and creating a more efficient market structure. Not too dissimilar from what other decentralized networks are able to do in more efficiently provisioning different nebulous resources, turning them into digital commodities. For example, Bitcoin being a hyper-efficient energy market, other networks provisioning other types of resources efficiently. What we're able to do with model coordination networks is start to provision machine intelligence in a much more efficient way and really start to accelerate the rate of progression that can be realized via machine intelligence, and do it also in a more, I guess, like aligned way in terms of kind of being aligned to the well-being and longevity of a good society. And so that's kind of what we're building. Another way to think of Allora is basically this abstraction layer for intelligence. Instead of a developer, a company, a project, whatever, integrating specific models when they're trying to leverage AI for something, they're able to tap into these model coordination networks that essentially stitch together many models and abstract away the complexity or the discovery process that developers or users are faced with today in deciding which AI model they need to use for any given task or any given use case. So that's another way of thinking about kind of what Allora is and what this kind of class of model coordination networks are more generally. And we'll kind of go quickly through this, but this is kind of how Allora works at a high level. Basically, the network is broken up into many different kind of sub-networks called topics, and each topic is defined by a distinct ML objective function. A simple objective function might be predicting the price of some asset relative to another, where the loss function is something like the mean squared error, and in that example, the target variable is the price of say Bitcoin to USD over some time period. And within each of these topics, there's a few core sets of actors. At the kind of core of the network are these actors called workers, and these are split into two subclasses. There are inference workers that are people running models trying to optimize the objective function itself. On a regular cadence, they're producing, in this example of price prediction, they're producing price predictions as a function of whatever model they've built or whatever methodology they're leveraging. And simultaneous to that action of them trying to produce inference to optimize the core objective function in a given topic, there's a second class of workers called forecasters, also running models, but instead of trying to optimize the objective function at hand, they're exploring this kind of more nebulous or undefined signal space, essentially thinking of it as context that may influence the performance of each of these inference workers in optimizing the ultimate objective function. They may be trying to discover if, for whatever reason, one model is more performant on Mondays, another on Tuesday, or if another model, for whatever reason, performs better in volatile markets and another in less volatile markets. They're exploring this, like I said, this kind of more nebulous context space and introducing this important additional dimension of evaluation or performance into the ultimate aggregation of inferences. And it's via both of these actors' tasks that at every sort of running of that operation, we're given an aggregate inference that represents an intelligently weighted set of inferences that are produced by those actors. And so no matter how many models are running, we're getting one aggregate inference that is sort of pulling the best pieces of intelligence from those core models. And then on a slower cadence, we're having this third class of actor, essentially model evaluators called reputers in the system. They're taking some evaluation criteria, maybe it's some sort of out-of-band ground truth, and they're leveraging that to assess the actual performance and, or more specifically, the actual losses that were realized by each of these kind of core worker types. And that's what becomes their canonical weight in the kind of beginning of the next run of the system. And it's through this kind of interplay of inference aggregation and sort of the intelligent weighting of different inferences that we're able to produce at the network level an aggregate inference that consistently outperforms any of the individual inferences that is contributing to it. And we can go into a little bit of how this works, but the key to like creating network level outperformance, or the sum being the whole being greater than the sum of its parts, is via that forecasting step. It's via the exploration of this kind of context space. It's pretty small, but we'll go through this quickly. But we can see in the kind of top row of these diagrams, this is the performance of kind of just the core inference workers doing a single run of producing a price prediction for like a given price pair or asset pair. And we can see here that the first predictor, the first inference worker is the best performing. They're able to predict the price closest over a series of runs. And when we then incorporate this sort of context-aware signal that these forecasters are generating, even just a single forecaster, the best performing forecaster, is able to produce a better aggregate inference as a function of introducing this kind of these contextual signals than the best individual model running on the network. And so this is, I think, the key of creating this significantly accelerated rate of progression for AI via creating this kind of efficient or hyper-optimized market environment for AI. And what this kind of unlocks, I think, is kind of a new paradigm for interacting with AI. And I think it's not too dissimilar. It's analogous to the transition from transactions to intents. So when we're interacting with blockchains via transactions, we're obviously specifying the specific state transitions we'd like to run on chain to achieve some ends. We are tasked with that discovery process of what the optimal state transitions are. We are one actor. This is often suboptimal. And what intents have done is it sort of offloaded this discovery process, this state transition construction process, to this efficient set of specialized market participants and solvers. And it's not too dissimilar to how we interact with AI today, in that today when we're interacting with AI as users or building with AI as developers, we have to do this constant exploration of what the best model is in the universe of models for our use case. This is changing constantly. This is a lot of overhead. Who's to say we're the best at doing this exploration, et cetera? It's quite suboptimal. And so what these kind of model coordination networks enable, what Allora enables, is this new paradigm, intent-like in how we interact with AI, in shifting from this model-centric paradigm where we're doing this exploration, we're constantly locking into specific models based on what we assess as being the best model for a given use case, and we're simply specifying what we want our models to do well or what we want AI to do well, and then enabling this efficiently constructed market for intelligence to produce the best possible inference. Many different models being coordinated efficiently to produce the best possible output for that kind of like rubric or that assessment criteria. And so we think this significantly lowers the overhead, increases the efficiency of actually interacting with AI, of bringing the best AI into different systems, things like that. Just some stats on the network. The network's been running in testnet since last year. It's generated many inferences, close to 700 million today. We've had about 300,000 workers come onto the network, so 300,000 people running models, contributing to the collective optimization of these different ML objective functions, and that's spread out across about 55 topics. That's north of 70 at the moment, but a lot of these topics are focused on these kind of DeFi problems. We see most of crypto's PMF to date being found in DeFi. AI is just meaningfully more mature as it applies to financial operations as well. And so a lot of the initial focus of the network and the types of problems that we're trying to coordinate models around has been kind of specific around DeFi as well. And so these are some of the, we'll go through a couple examples of projects in the ecosystem that are leveraging the network today, but they kind of span these DeFi verticals. Like I said, DeFi is where the majority of usage in crypto is. AI is quite good at making DeFi more expressive. DeFi is powerful because it has enabled us to sort of construct these kind of hyper modular financial primitives in a highly composable environment. But DeFi is limited because it only has access to kind of primitive deterministic compute. AI is the most expressive, deflationary compute we've ever had access to. We are able to significantly level up the kind of types of DeFi primitives we can create by introducing this source of expressive non-deterministic compute, i.e. AI, into these systems more tightly. And so this is an example of an AI agent that was built leveraging the network during the kind of US presidential election season. A topic was spun up on the network to aggregate many different election models and then produce single aggregate inferences on a regular cadence from a myriad of different US election models to inform an agent trading on the polymarket election markets to then trade based on what those aggregate models were output. And it was able to trade like a mostly delta neutral strategy or a highly hedged strategy over a period of a few months leading up to the election and generate a rough APY or kind of annualized PNL of around 68%. Again, just by tapping into a set of models that are being coordinated via the network, not locking into a single publications model or a single opinionated model, but taking the best pieces of many different models and then using those to inform a kind of intelligent strategy for trading these markets. This is an application live today that's a bit simpler in scope, just leveraging a topic on the network for trading Solana directionally. It's a directional trading strategy, opens long or short positions based on Solana price predictions that are running on the network. So there's a Solana topic for predicting the price of Solana to USD on a regular cadence, in this case 8 hours, many different models running on it, all leveraging different methodologies, all taking kind of different tacks or angles in producing useful inference. It's taking those aggregate inferences and using those to inform a trading strategy. It's performed quite well. It's doing about 24% APY, but it showcases the kind of outperformance you get when you are able to efficiently tap into a basket of models being efficiently coordinated as opposed to locking into individual models and needing to update those constantly or build them yourselves, things like that. Then the last example here, we did a project with PancakeSwap. They have a fairly simple prediction market product where users are tasked with betting with or against or sorry, betting if the price of ETH to USD is going to go up or down the next 10 or 20 minutes. This is just leveraging user inputs initially, and so it's just users betting against each other. An example of kind of how like multiple models can improve these types of games as well is we built a variant of the game with them that basically takes predictions from the network of whether the price of ETH USD is going to go up or down the next 20 minutes, and then have users bet with or against that AI. The AI is right a lot of the time, so they get a lower payout, but a more consistent payout if they're betting with AI. But we saw this kind of meaningful uptick in the usage of the product as a function of integrating this sort of out-of-band like machine intelligence into the system. And these are just a few of the projects that have been live to date. There's a myriad of different projects or products that are leveraging the intelligence across like active liquidity management, making money markets or lending protocols more expressive or capital efficient, a lot of stuff with AI agents, a lot of stuff with AI-powered vault strategies. And yeah, that's just a quick look of like some of the projects that have been leveraging the network to date. We're across a bunch of different chains, integrated into basically all of the major kind of agent toolkits or DeFi SDKs. And it just makes it makes integrating AI into these systems and or strategies very simple, and it creates this kind of like ultra abstracted experience. No discovering AI models, no building AI models yourselves, just specifying what AI is meant to do well, what well looks like, and then easily integrating those into these systems. So that's a bit of what we're doing. Do I get off now?